Good morning and welcome to CAD-1's BIM Energy Analysis Part 1, Leveraging Revit for ComCheck and ResCheck. My name's Stan Henne and I've got on my left, your right, Brian Juge, Brian D. Juge, AIA. And this is an interesting presentation today. Energy in general and ComCheck, ResCheck are not necessarily settled law, so to speak, in all the ways you handle these topics. So we're going to give you kind of some of the guidelines and some of the things to look for today. And in our part 2, which is next Tuesday on, which day is that? The 17th at about 10 o'clock. And just a reminder to you that Revit Radio is this afternoon at 1 o'clock, and the antics of the boys will continue once again. And then we also have Brian Mackey and I believe Mr. Juge is participating on a detailing in Revit webinar at 3 o'clock this afternoon.
No, I think I'm going to have to miss that one, Stan. I've got
okay.
another thing I got to be doing.
Details.
Details. But with that, yeah, we're going to start talking about Revit and kind of how we can leverage some of the features in there for ComCheck and ResCheck throughout our process. Hopefully many of you have been looking at the attendance here. Our architects out there, because it tends to be, this is one of the areas where the responsibilities pretty much solely fall on us to handle the project out there. Well, change color schemes.
The GoToMeeting folks like to throw all sorts of weird things at us every time we log in, it seems like.
With that being said, I'll just go through the little our standard slides here and get through the hey, can you hear us type of thing and ask your questions and stuff. So if you can hear us, let's see, raise your hand. You've got the little raise the hand icon there on the left there of that little dialogue. Also, if you want to minimize the dialogue, you can hit that little orange arrow, pull that away. As always, you have the question area if you want to ask some questions. And I just kind of wanted to find that a little bit in here that if there's any kind of questions that you want to ask, that'd be great. That being said, I'm just going to do kind of a general overview. When I was putting this together, it was just, hey, I was talking with different people. Were you aware that you could do ComCheck and ResCheck? And most of the people I talked with said, you know what, we actually outsource that. We send that out to someone else. And I said, you know what, it's really easy to do. Why don't you just assume the responsibilities yourself? It's not like you're really liable for that much more than you would be stamping the drawings anyway. So take on that, take off those funds. I've seen people charge $500, $600, $800 for doing a simple ResCheck or ComCheck for a project, and it's really not that difficult to do, so might as well put that money in your own pocket, something that my team will actually offer as an additional service. Wow, that just keeps the pop up today. Keep the color scheme. Don't. All right.
Well, and if nothing else, it gives you. We're going to give you a little bit of hint on how you can, set your models up for this kind of work and, run the checks yourself, at least as a preliminary, so you know kind of what's going on.
All right. So here's just a quick quote taken from the website there, and you can read it yourself. But you can say it's ComCheck products. If you're maybe you got your screen turned off, so I'll read it for you. The ComCheck product group makes it easy for architects, builders, designers, and contractors to determine whether a commercial, high-rise residential buildings, additions, and alterations meet the requirements of the IECC and ASHRAE standards 90.1, as well as several state-specific codes. ComCheck also simplifies compliance for building officials, plan checkers, and inspectors by allowing them to quickly determine if a building project meets the code. Okay.
And then for those of you who might not have known what the actual definition of is, there you go.
There you go. And the ResCheck is the same thing. It's just applying for residential buildings. So we have the simple thing of evaluating that there. And then we have this little flow chart diagram on the right there, just identifying how this process is to take about. And you can read that. I won't read through the whole thing there, but it's basically evaluating the project, running it through the code analysis, determining which code you need to follow, then running that through the analysis, and then bringing that out there. So with that being said, I'm going to jump over to a quick website in here. So we've got our different res check. And pull that one over. Bear with me just a second. So I'm going to go in here and get to the different building requirements. So most of the people, if you're not familiar with it, this is the U.S. Department of Energy. This is where you're going to get most of your information for it. And I'll just go in and do kind of how you would go about detecting what kind of CommCheck or ResCheck you get out there. And this can be either downloaded to a website or can be actually run on the website itself. So you can either download the program or run it yourself in here for that model. Throughout the process, you'll get into determining how or what code compliances you're going to get. And I'll quickly go through this right now, actually. So let me get in here, get back to my slideshow, and we can see that this is the state requirements here for what Colorado is going to have. Now, looking at all the states out there, Colorado actually basically has the minimum requirements less than any other state. IECC 2003 is the code compliance that we have to follow for both CommCheck and ResCheck, whereas the rest of the nation is pretty much in 6 or 9. Some are adopting 12 as of yet, and you can see where they're going with that. So here is just a sample of a specific project I've pulled up in here where I'm using Summit counties in here, and it's breaking it down by climate region. So not only are you following the code requirements, but then you have to go in and select your climate region. So this is all through the website in determining what kind of codes, what kind of minimum requirements you need to have for each of these areas. And you can see here for climate zone 7 and 8, we have the different R values that we need to achieve within our ceiling, so that's why we're speccing SIPS panels and things like that to get that R50 or R49 that we get in there, to have our wood framing values and R21 in our walls, or massing, which I tend to do with the log homes.
Now, probably most of you know Revit reasonably well, and looking at the list of attendees' names, know most or a good many of you, and know that you're reasonably proficient to very proficient at Revit. So as you start looking at these code requirements here, you can start thinking about, okay, as I develop my Revit model, here's what I would need to set up, say, a family for a particular wall, or whatever it may be. You can start deducing what you would need to do in Revit to set your model up correctly as we go along, and we'll show you a little bit more of that in a bit. By the way, this will be recorded and on our YouTube channel probably sometime next week or the following week. It takes a few days to get up there. So
okay. And here we can see kind of I call it the interface challenges, and actually I did spell challenges wrong, so that's kind of interesting. But interface, it's challenging to spell challenges. Okay, so need to build in the schedule. So the difference between ResCheck and CommCheck is we can actually leverage the model directly from a commercial model directly into CommCheck. In ResCheck, we need to build different schedules and assets and stuff for the walls and windows and doors in there. And this tend to be a more manual process for that. But the ability to Revit to go in and build and have the schedules built for us, we'll have to put additional parameters into those schedules so that we can get things like area, because area doesn't directly come out of, let's say, windows and doors if you're using those glazing values in there. And then to start looking at what's a conditional space versus unconditional space. So we might have to put additional parameters on doors and windows and walls in there so that we get the proper values out there. The way that the ResCheck works is it's just looking at what's the conditional area. What do you have insulated in your building volume? So you have things like attic spaces and stuff like that. If those are unconditioned, those particular areas aren't taking into consideration when you're doing the ResCheck calculations. The CommCheck's a little bit different. We can actually go in, set up the model itself, have our different values for our walls, our rooms, our areas, and then we can export that out as a GBXML file. We need to set that project up with the rooms and should have a basic understanding of what is being leveraged out of the GBXML model. All right. So with that being said, let's just jump into model right now, and I'm going to go in and not fire up my Revit. That's the old Revit program. So I've got let me start with the res check here. Apologize. Unfortunately, it wants to fire up my old version of Revit. And I'm in 14. I'm not in 13 anymore. All right. So here we have a cabin that did not too long ago, this past year. And I've got the particular requirements, and then I can pull up the res check requirements we have in here. So I have the project information, what county it was in. You can see it's Summit County, so that's where I was getting and leveraging that information from before as far as what were the minimum values out there. Now, one interesting thing to point out is that when you're looking at the code requirements, I can go in here and access the code and determine that. I said that Colorado is the only state in the union that's still out there in IECC 2003. Well, you can't pull up the code requirements for 2003. The latest one, the oldest one you can grab is 2006. So that's pretty much what we've been basing our code analysis for, whether that's online or on your hardware. So we've got some that information in here, and you just pick if it's, you know, what state it's at, what kind of county it's at, what kind of is it new construction or condition space. So you get it all out there. You can pull the data out from your model and determine the owner's name and everything else. After that, we get into, okay, now we've got to build all these assets. We have to go in and build the floors, build the walls, put the windows in each side of the wall and the doors if they have glazing on it, and start getting these things in here. And it becomes a big manual process. So I'd come in here, and if I'm starting with a new line inside, I start with a wall. And you can see it starts making a wall in here, and then I grab and I determine, well, what kind of wall is it? I've got wood frame, I've got log, and this one's typically log. In here I have to determine the sizes for that, and I'd fill all that out. And then determine is it front, left, right, side, back, whatever we have for that, and give it the gross area. We can see this is very much a table like what we could get out of Revit. So instead of just manually going back and forth, which I still have to do the manual process, but I'm going to build some schedules to help leverage the data out of there. Okay, so inside this project here, what I've gone and done is I came inside and I built some schedules in here, and I'll look at what kind of schedules we had to build. So I've got some wall energy schedules, just giving my family, my type, what kind of wall I'll have in here. And I might have the different things, the different functions. So if it's exterior foundation, I'm going to have to go in and filter this out. And part of that process that I did was I immediately went in here and I filtered out anything that was an interior wall. I don't need those interior walls. I just want everything that's on the exterior. You might have to have some other designations built into your project. So you might have to classify different walls as different types, or because of the way we're building Revit models, combining walls together so that we're getting a combination. Instead of doing every little area of every different wall, I might have to assume, okay, all four of these walls are actually one wall, and group that together. So there might be some other additional things to put in here. Inside here, we have different areas of the walls, but if I need to start looking at conditional areas, I'll go in there and create different values. So inside of this project, I've actually done a ceiling height. Now, I didn't actually need conditional areas in here because all my wall areas for this project were conditioned. I had no attic space. There wasn't any leftover room or anything like that. It was just basically a square cabin, throw people inside of this particular project. So most of it fit with that conditioned space in there. And I think we've included the garage as a conditioned space because they wanted it heated and they were doing this other stuff inside here. But I went in and I built the ceiling height. So if I needed to set a condition space, I can put that in there. And the way this works is I went inside, I grabbed the made a project parameter, created a ceiling height. That was a common parameter in length. And then I just grouped under dimensions. So if I ever came back to a wall, I could assign a height. The overall height of the wall could be 12 feet, but the condition space, let's say the plate height was set at 10. So now I can say, well, this is a 10-foot height. After creating that, I came in and I did a conditioned area. And in that parameter, it was a calculated value that I set up for.
And Brian, real quick, we've got we've got a comment from one of our attendees who mentions that you also need exterior walls to be filtered by orientation, which would make sense because, you know, some walls are going to be in the shade and some walls are going to have the sun falling on them or partial and so forth. So
exactly, and one of those areas I've kind of left that up to is I don't always use the description area, so we can go in and leverage the description area. That's why I included in the list to assign is it a north, south, east, west wall for that, and then I can group all the north walls together, east walls, and south walls together to get that data together. Now, when I did this res check, I hadn't gotten all that figured out for this particular one, but this is thinking back on this process. Man, this was so labor intensive. There's got to be a better way. That's what kind of drove me to say, well, let's leverage this in Revit rather than going back to my old Excel spreadsheets and stuff. Let's put the tools to use. And that's why I built this class, or built this webinar, was to say there's a better process. We're already having these tabular formats. Let's go and use that instead of trying to make this so much a manual thing. So yeah, I use that description for determining if it's a north, south, east, west wall in here. So for the conditioned area, that's again a calculated value. And let's go look at what that was set up for. So it was set up as, I just said, conditional area. It's a formula. It's a discipline is common. The type is area. And then I just said the width, which we already have generated from the wall, times the ceiling height, which was a parameter that I had already set up that's in part of the walls. So I can go in and multiply those two values together to get what my condition area was if I needed that for the project. Again, most of my residential projects, they're pretty much conditioned as cabins or vaulted ceilings. There's no cavity space in there. Okay. And then looking at that, if we go back to the model itself,
while you're getting into that,
there we go.
You will note I look at the attendee list, and obviously we're using the Colorado example. I know there's several people here from Wyoming and a few people from outside the area who join us. These same parameters are available for every state and so forth. So don't get fussy about us being just Colorado.
And I should point that out, that I believe most of the other states are in 2000 or 2006. So I'm still using the same code requirements. It's not like I'm looking at 2003. They just said that Colorado has to apply to 2003, but they don't list the 2003 codes. The actual CompCheck and ResCheck are using 2006. They don't have the code compliance for 2003. So this would apply to most states out there, actually, that are using the code right now. We can look in here at the wall area. So I go and select one of my wall areas inside here, and I've got my information. I've got the area in here, but if this was a certain conditioned space, I can go down here to ceiling height and specify specific ceiling height as being conditioned. Maybe just the first 8 feet is a conditioned space. Now when I go back into that schedule in my project, I will see that there'll be a different value set up in there for my, that's the door designation, the wall designation in here, and giving me, what that total area is going to be, the width times the height of that, the width of the wall, giving me that conditional area in there. The other thing we need to do is go in and set up our doors and our window schedule. So I actually go over the window schedule in here. I've got all the different windows. I've also set up the wall designation so it corresponds with the correct wall. So when I set that wall description, I'm going to put the window description to follow the wall description in there. So if this is the north wall A, I would put that wall description in here so I'm getting the right window inside the right wall. We can get width and heights within windows, but one of the parameters that doesn't show up that we need to build is a window area. So inside our fields, one of the things you're going to need to come in and build is some way of getting a window area. Again, that parameter, I can add a parameter, so I'll just put W area for now, and I'll fill this out for you. But it's going to be an area parameter. Whoops, actually, it needs to be a computation to calculate value. So I'll put that in here. So it's a W area, common, and then I just got to make sure I'm selecting area, and then I come down to the formula and just make sure I'm grabbing the width and height of that particular format in here. And if we need just the glazing area, I would go in and get some way of doing just the glazing itself. So you can see how this is being done and then kind of tailor it for your needs in there. So,
Brian, we got a couple of things here. One, we have one of our attendees who attends many of our webinars and is pretty knowledgeable in the energy area and MEP area and so forth, so often provides some very valuable comments. Juliana says, or notes, if you have a large model, your description parameter for each wall will be very labor intensive. There is a small free CASE apps that helps with that, and the beauty is that the GBXML file takes care of this automatically. So just pass that along. And then James asks, your width, a question, your width is the thickness of your wall, question mark. That doesn't seem to provide the conditional area you are looking for.
yeah, and you're correct. I grabbed the wrong parameter in there, and what I needed was the length parameter, not the width parameter of the wall. The whole length of the wall area that I'm looking for, not the width. So I unintentionally grabbed the wrong parameter out here. So we don't need the thickness of the wall, except if I was doing log. I have a width parameter in there for my log that gives me the actual ratio of what the log parameter is. So I use that for another purpose, and I apologize on that. So I have to go inside of my wall parameters and grab the length one and then multiply that by the height or my ceiling height to get that value out there. So it's a good catch, James. I realized that after I plugged that in there, and I'm like, oh, that's not actually giving me the right value. But when we're dealing with logs, we have to deal with the whole ratio of the log. What's the actual, I forget the proper terminology, but the true thickness of the log as it's being tapered down. Okay. So yeah, for doors and windows, we're going to need to go in here and grab the width and height and create a window area, because that it does not reside in here. And then going back to what another comment was, that Chase app. That's a great app out there. Unfortunately, don't have those loaded here. But being able to designate your wall areas and having that transfer over when we do the comm check is going to be a great asset. We also can grab the solar heat gain and thermal resistant value, the light transfer, all this other stuff that we may need to take advantage of in our next process in here. So now we've got that value in, it comes to a matter of just plugging this in. Unfortunately, this still becomes more of a manual process that I'm seeing at this point, but at least I have the schedules in here. I now can go in and start plugging this data inside, giving me my areas, looking at the U values and everything else that would be appropriate for setting up my projects. Okay. So again, just a kind of a general overview, getting some people who have never looked at this before, this process before, getting their feet wet a little bit out there. All right. The next one I want to focus in on is looking at a project, more of a commercial project that we can have out there. And this would be one that we can start using for sending out for a GBXML file. Okay. So one of the things that Revit can do, and again, this unfortunately only applies for CommCheck. It doesn't apply for ResCheck. Is in a CommCheck project, and here's the CommCheck interface. I can actually go in here and import a GBXML file. Unfortunately, with the ResCheck, it's not available yet. So I would say start screaming at them. Say, hey, let's get this as part of the ResCheck. That would be a great asset for the rest of us to take advantage of. Okay.
Yes, and all they do here is screaming. So
it's screaming.
Scream loudly.
Scream loud. That's all they hear. Exactly. Okay. We need to prepare the model for getting that GBXML information out there. Some of the nice things that we can do is actually set up the rooms and stuff in here. But we can see as I'm preparing this, so I'll go in and export this particular model or get it ready to export. I've got this inside. The first thing I need to do is set up all the different parameters so I have the proper locations in there, and then it's the proper building type. I mean, it's just kind of setting it up for any type of energy analysis, and we'll get into this next week too when we get into more of this. So what's the building type we're putting in here? It's got set as a parking garage. That happens to be the default, so I'm going to go to an office building. that we can put in there. Where's the location? Virginia Beach, Virginia? No. We need to come inside and determine where this building is going to be located. So if I know that this is in the Denver area, I can go in there and type that information in and find out where we're located at. So, you know, maybe we're up in our neck of the woods up in CAD-1. I can come inside here, place that building, and get close. 120th. There we go. Check that out. Pretty close. So we have that in there. I've got the satellite imagery. I can pull that up, really place it with the proper location that we want through our project. I think it's this right there. And it's going to look for the longitude and latitude. The other thing we'll have, and you'll get to access more of this if you log into your subscription account, but we'll start looking at local weather stations, and we can actually start seeing local weather data. And again, we'll take advantage of that a little bit more next week.
And for those of you who are familiar with Revit Radio, you can actually see the Fuddruckers parking lot on this aerial photograph. So it's a twofer today.
There you go. So there we are there. I've placed it in there. The other thing you're going to need to do before we get into this dialogue is actually have the orientation set so that you have the true north and the proper location. We've set our ground plane up, so it's level 1 or the basement. Maybe you have a walkout. You have to go in and start determining these types of things in here. It just becomes good management. The export category we can do as rooms or as spaces. So if some of you are in the mechanical area and you've got spaces set up, you can go in and switch over to your spaces in here. We've got some other things, including the thermal properties of what's inside the walls if we want to push that out. The other thing we'll have is checking on the details. We can go in and do the rooms and set up the rooms in here. We can see all these are checking out as being fine. But if there's some area that isn't quite properly conformed, we can go and check that. And that'll be followed up with a red X. This tool is a little interesting. If I try to highlight a building, it turns it blue. We can see that it's turning it blue, but sometimes it's really hard to read in there. So what I like to do is if there's something in conflict, I will select it and go in and isolate that area. Okay. Now I'm going to make an assumption. Hey, maybe you have some errors in here. Let's go and see what Revit's looking for to pick up to clean up this model so that it's working properly. Okay. And that's all going to be the room. So I'm going to come in here and just draw a section in here inside. The other thing we're going to need to do is turn on our volumes. So if we haven't done that already, and I believe I have in this project, but I'll go into architectural, rooms and areas, and I want to turn on the volume computation. So I'm going to have to come in here. Oh, I haven't. So I'm going to go in here and do the area. Instead of just the areas, we have to say the areas and volumes. And that's important so that Revit's going to pick up on those in here. So now I'm going to go in and cut through the section. And the next thing I'm going to do is turn on the rooms and make sure I've got the rooms at the proper height. So I'm going to go to my visibly graphic overrides. I'm going to go down into my rooms, and I'm just going to turn these on so we can see the checks in here. And actually, I don't have those. If I send out the GVXML file, now I know I'm not going to have those will be in failure, and I'll show that right now. So again, I'll go back to the export in here into the details, and we will see, yep, I have a lot of conflicts in here where I'm not properly getting these volumes to show up. And if I go in and highlight those, you can see these rooms are in there. So I have to go and clean some of this stuff up.
Michael, I see that you raised your hand. If you have a question there, oh, you just typed it in. Good. What version of ComCheck are you currently using? Michael asked. Do you know?
The version of ComCheck I'm using right now, oh, I just downloaded it again the other day. So what is it? It's 3.9.2 is what it's telling me, and then the code I'm looking up is 2006. But again, I could go in and look and check on different code values in here. And if you're in specific states, they have their own version in here, but again, not for Colorado. Okay. So I need to come in here, correct all these different areas inside. So I'm going to grab these ceilings, pull them up. Another quick way of doing this is just going in and selecting all the volumes in here, filtering out and just getting the ceilings, I'm sorry, not the ceilings, just the rooms throughout the model. And then what I do is I've got the upper limit. Instead of it just being one level from 1 to 10 feet off of 1, I'm going to actually go to 1 to 2, and the level offset I'll set as 0. Okay. That'll correct all these room volumes in here, and you'll see they'll snap up, except for this lobby area. I'm going to have to come into this one and stretch that all the way up so it's properly enclosing that room volume. And we can see this in this section over here. So I'll turn on my rooms and areas in here just to show you some interesting things that are happening with your room volumes as we're doing this process. So I've got the rooms in here, turn those on, turn in my interior fill. We can see this is what's going on. And one of the interesting things that happens is rooms will detect their horizontal boundaries really good, but not the vertical. What it's going to do is it's going to come up and hit a ceiling or a floor, and then it just goes straight up. It's not going to cut back in and pick this volume in here. So if I really wanted to do my due diligence on this building, I have to create another room for this space and another room for this space. You can see how it's cutting around these spaces in here. So here's another room. Pull that up, and you can see it's pulling up to that volume. Now, a lot of times, if we're not properly enclosed, we get these little shafts of, I don't know, energy leaking out of your building. And that has to do with cleanups and stuff within our models. So we have to make sure we're having a properly enclosed model in there to get these volumes to work out. So we'll just go through the model. And again, one of the fastest ways is just going in, selecting everything, going in and filtering, just grabbing those rooms.
You got an error message on the screen here that your computer is overloaded.
My computer is overloaded. So I've got the upper limit. Again, I'm going to do that 1. I'm going to put that down as cancel real quick.
Can you turn it off? Because that's what the folks are seeing there.
Oh. I don't even see it. Error message? That's funny.
That is funny.
Are you sure?
There it is. We'll get it out of the way.
Oh, there we go. All right.
Okay, good.
So we're having technical difficulties there. I don't think I was having the error message, Stan. I think that was your computer.
I think it was on my computer, wasn't it? There. Yeah.
Okay.
Sorry about that.
Go back in here. It's no big deal. So I'm going to grab these, filter out those rooms again. Upper limit, set it to 1. Offset set to 0. Must be higher than, sorry, not 1. 2, that's what I want. That's the floor above. 2, then we set that to 0. Now I've corrected most of those rooms in there. This one is still up to the height. Now if I go back to my GBXML process, export that, you can see I've got the funky little volumes in here, but if I get into my details and I go back to level 1, I've cleaned all those errors up. Those are no longer in there. In addition to rooms, we could have just went in and did Analytical Surfaces. Select on that. And what that's going to do is give us different faces in here and color code that to all the different facets and faces within the model. All the trim area gets a designation around the doors, all the mullions around the windows. And so this is another way we can go in and send it out for energy export in here. When we're done, I'll just go to next. I'm going to come inside and drop this into a location. So I'll put this right on my desktop in here. Always a great place to save things, I know. But with that being done, now I can get into the COM check, go in and open up that model. That's another one in here. But now I can go in, actually go to my desktop there, and then I'll grab my res check model. Oops, I did the wrong process. I want to open. I want to go in and import a GBXML file. That's the one I want. Now I can go in there. There I have that mid-rise energy model. Open that inside. It's going to tell me it's going to take several minutes to do. This shouldn't take too long to bring in inside here. But we can see we have the project information that it'll bring in. It'll pick that up. It should pick that up from the model. It'll start giving me the envelope. And then in this case, I didn't have any interior lighting or exterior lighting. I have to start putting that information in. But had I have that in there, I should be able to start. I'm assuming I haven't actually done that process. So I always have to do that manually. But maybe someone in the mechanical area could chime in and say, hey, does that carry over too? I'm not quite sure. But I know that the envelope information is going to transfer over inside here. So So here I start getting some of the results out here, which is east, south, west facing, inside, all the doors that will be involved in that. The assembly wasn't quite picking up on that, so I have to go back and probably refine that a little bit in there. But I got the construction details, the gross area for that, giving me the U value inside here. And then as you're going into the process, you just come in and fill out anything that happens to be full of red in here. Now, if I wanted to, I can go in and add more information to this particular project if I needed to manually. So if it's something I missed, I can go and pick that up. That's kind of where we are at today with this. I just wanted to give a brief overview of what ComCheck and ResCheck can do out there, and that there is some workflows, at least on the commercial side, where we can go in and bring the energy model in directly from Revit using the GBXML process. Okay.
Hey, Chris, can you type your question in or your comment in so we can see it? Otherwise, you're just waving at me.
Maybe that's a virtual slap.
It may be a virtual.
Yeah, we might be getting one of those again.
Chris is pretty good with his energy knowledge, so. I missed the
first part. Well, I'm not gonna.
We
recorded it.
Do it over?
Yeah. What do you want? Oh no.
Where did you get the energy schedule? It is recorded, or it will be recorded. It is being recorded, and it will be up on our YouTube channel. Brian created the schedules in Revit by going through and adding some parameters to the wall types and door types and so forth. Now, one of the things, and I think it's worth repeating, Brian, that you were using ComCheck there when you brought that GBXML across, and you were saying that ResCheck didn't have that luxury yet.
No.
So you have to kind of follow a manual process on the ResCheck side of the fence to do such a thing. And I know you're trying to bring up some examples here, but yeah, Chris, he went in and he used the schedule side of Revit to create some schedules that could be exported across. So hopefully, if you have some questions on it, give us a call and we'll talk you through them.
Yeah, and I guess it's important to point out here that actually built with inside of Revit, this is new to 2012 or 13. I think 13 is when they introduced that. So from 13 to 14, you actually have the R values built with inside the walls in this processing here. And that's all coming from the materials parameter. So if we were to go in here and look at the concrete masonry unit inside, and I'll look at the material assets that we get out of this. So when I look inside of this parameter, we can see that we have all the data that we're used to. So what's the name of this particular thing, the graphics that we get in the appearance. But now we get some other things. We have one that's for the thermal properties. So we're starting to see this thermal property data in here and the information associated with it. This is mainly coming from ASHRAE to give you these figures in here. Now I have a big, kind of like my own personal beef with it, is because, okay, I'm hearing that this is coming from ASHRAE, but the only problem is that the source is Autodesk, and I'd much rather see, so you guys can start complaining with me and say, hey, instead of listing Autodesk as the author and source, why don't we put ASHRAE as the author and source for this information in here, and then I know I can be leveraging it. I've had some people, not personally myself, but go back and verify some of this, and they're saying, yeah, it's pretty much coming from ASHRAE data out there. These numbers look like the same numbers out there. So at least on some of the material, it looks like it is. Now, I haven't checked every single material project. There's thousands of pieces of material. I don't even know if anybody has the time to go out there and do that. But at least on some of the main ones that we'll use for my projects, yeah, it looks like they're getting that data from there.
Well, and I think this brings up a very interesting topic in the whole energy area right now, and I think it is getting better and so forth, but we see a lot of kind of odd standards depending on what tool you're using, and you kind of go, well, I don't know that I'd want to bet the farm on that. Whereas, so when you see Autodesk on this rather than ASHRAE, which is a kind of a governing body of sorts, it does kind of make you scratch your head and go, well, you know, if I stake my claim to this, and then it proves out kind of not right and just something Autodesk did, not that Autodesk is trying to do anything wrong, but still, you know, it brings up some interesting issues.
Yeah,
potentially.
It seems like Chris had a question on there. It says, so if I create a set of materials on the walls, is there some place where the comprehensive wall R value is listed, or is this manual? Oh, it says, never mind, just saw it. So yeah, that is it is calculated for you if you're using Revit 13 or 14 out there. Those R values are coming over, or U values, or thermal mass values, I should say, are coming over for that. And you can plug those in. Again, take it with a grain of salt. I tend to round down for those materials, or I'll verify for what, you know, I'm looking up in just a standard code book, saying, okay, if I have a 2x6 wall that's insulated, and I have a stone exterior and gypboard and maybe 2-inch layer of rigid insulation, what is that typical R value? Okay, I'm in the ballpark. Maybe if I need that value, I'll list the one from Revit. Maybe if I'm okay, I'll list the one I get out of the manual or the book process. But it seems more and more that this model, and we'll look at this a bit more next week, they're fully relying on this, taking it into green building studios. So the more I do the research, the more I'm saying the data seems to be sound. And I'm relying more and more on it, whereas in the beginning I was real skeptical, and I wasn't married to, hey, these look like great values, and using them. I was like, well, I've got my stamp on the line. I'm going to tailor it back. I'm going to round down on my values, but at least I'm able to double check it. Now I'm a little bit more satisfied with the R values I'm getting out of the materials.
So good. That's a good starting point. I hope you all got you know, some good out of that. It's not terribly hard to do if you set things up correctly. Brian, do you want to, you know, you alluded to what you're going to present on the 17th at 10 o'clock. Is there anything else you want to use as a teaser to lead us into part 2 of this?
I'm just going to say there's a lot of beautiful tools out there that most of us have at our fingertips. The ability to go in and run this energy analysis on the cloud and submit it to a building department. Sometimes it just seems to be a little overwhelming. But another great thing is you now can focus in on those areas. It'll identify the areas that you need to focus in on the greatest energy savings, and it's going to make processes like lead and lean a lot easier to quantify what you're doing and to show owners, hey, this is what's going on, and you just have the tools there at your fingertips to play with. It's going to be fun.
Well, excellent. Thank you for putting this together. Brian was telling me that he's got 4 very young children, and that they all decided they wanted to spend most of the night awake last night. So
yep.
he was scrambling a little bit this morning. But anyway, thank you, Brian. And that webinar, the part 2 of this, will be Tuesday the 17th, again at 10 a.m. Mountain Time. So we hope you'll join us for that. We do have Revit Radio today at 1 o'clock. A lot of fun to do, and Brian Mackey and Brian Juge will be back for that. And then Brian Mackey will be doing his part 3 of detailing in Revit this afternoon at 3 o'clock Mountain Time. So I hope you can join us for some of those things. And with that, we'll sign off and wish you a good rest of the day.
See you later.
And Merry Christmas to all of you as well.